There we go. Awesome. And then I'm going to share my desktop. It's okay. And there. Andrew, can you see my math lab? It might take a second to load.
There it is.
Good. Okay. TJ, how about you? Andrew, I can't see if TJ says something just because of the way that this works. Can you let me know if he sees it okay? Oh, I just brought back. Maybe I can see it. Okay. It's really small in the corner. I think you have to go up to the top right-hand corner, TJ, and do full screen view. There's little icons at the very top far right.
Yeah. There's a couple of them you can play with. There's one like pick a layout, and then there's
Yeah,
full screen and whatever. So
one of those should work out to make it bigger. So I don't think I can do anything from my end. Let's just see here. Nope, give control. Nope. Oh, okay. Um, yeah, TJ, try some of those, but it is recording, so when you go back and watch the recording through YouTube, it will come back. But you already said that you've got this figured out now, so that's great. But I'm using TJ's question, and this is the one where it says to graph the following exponential functions, and you can see that we have f of x is equal to 2x and g of x is equal to 1/2 times 2 to the power of x. And it's a bit frustrating because if you were going to go and use question help and it says like help me solve this, it would tell you to do a table of values. So you would do negative, make your x values -2, -1, 0, +1, +2, and create your table of values. But there isn't a place to put your points when you go to graph. So when you click here to create your graph, there isn't a table of values, so it's a little bit frustrating. So in the playlist that I posted on the news feed, if you scroll down that playlist to the last two videos, there are two instructional videos on how to use this grapher palette, and I'm just going to show you a couple of hints when you're using it. So in terms of exponential functions, the parent function of uh, uh, y equals b to the power of x. If you're looking at the parent function to that, what you want to do is put a curve in that goes through 0, +1, because what we find is that all exponential functions pass through, or all the parent functions pass through 0 and 1 until you do a transformation on them. So if we start off with that parent function, and the first thing you're going to do is use the exponential tool. So I'm going to click on that, and then it wants you to place a point, and that point is going to be at the 0, 1 mark, and that gives you your parent graph. Then what you can do is you can say what the base is, and you can see that the base here for both of them, now the base is going to be the base of the exponent, so both of these functions, f of x and g of x, have a base of 2. So you want to make sure that your base is going to be 2. Now it wants us to draw both of these functions, f of x and g of x. So I'm going to have two curves here, plus it also says to graph the asymptote. So if you don't graph the asymptote or either of the curves correctly, you're going to get the wrong answer. And unfortunately, it doesn't give you a whole lot to go on why you got it wrong. So that's why I'm going to show you how to do that here. So right now I'm just graphing this f of x equals 2 to the power of x. My base is 2. And in terms of my transformations, I'm going to keep my vertical stretch or shift to 1 because my c value, which would be what I'm multiplying my base by, is going to be, if I have a base of 2, then that just stays at 1, so I don't change anything there. And my horizontal stretch is what I'm multiplying my exponent by, and in this, my exponent is not being multiplied by anything, so we just assume it to be 1. So this would be the settings if you had just the plain parent function of f of x is equal to b of x, and you're just changing your b, so your base. So you want to make sure that your vertical stretch or shrink is 1, set to 1, and your horizontal stretch or shrink is set to 1, and you don't have a vertical shift and you don't have a horizontal shift because you're not adding or subtracting anything to this function. So once you have that, you can click out of there, and then that's going to be one of your functions. And now I'm going to go ahead and graph my second function. G of x equals 1/2 times 2 to the power of x. So again, I'm going to plot another point, and this time I'm going to change my base is 2, so I'm going to leave that, but I have 1/2 times 2, and this 1/2 is a vertical stretch. So I'm going to change my amount here to 1.5, and you can see that that shifted my my graph over, and that's the vertical stretch of 1/2. So that's how you graph the two graphs separately. You want to use that exponential tool, and you want to drop the y-intercept at 0 and 1, and then use the data here to change the shape of your graph. But that's not it. If I were to hit save and then check answer, it wouldn't say I had the right answer because I hadn't graphed the asymptote. So the last part is to graph the asymptote. But in the asymptote, when you do, the only time that the asymptote is going to change is when you do vertical shifts and horizontal shifts. So in this case, we haven't changed the asymptote. You can still see here that it's at y equals 0. That's the point at which the graph approaches but never meets. So to graph an asymptote, what you want to do is, asymptotes are lines. So you want to grab the line tool, and you just want to pick 2 points to graph the line, but the asymptote has to be dashed in order for it to work properly. So that's a little hint. Always graph the asymptote with using the line tool, and then make it a dotted line, and then you can save, and when you check the answer, it will come back and say that you did that correctly. So again, when you're using this tool, you're always going to use the 0, 1 as your y-intercept and your parent graph, and then change your transformation data to fit whatever function you're given. So you're going to need to have an idea of whether you're working with a vertical shift or a vertical stretch, a horizontal shift, a horizontal stretch, or a reflection. And I was telling Andrew and TJ earlier that I have some notes that I am going to print off, or sorry, type up for everyone and post in the news feed tomorrow that just gives an overview of what to look for in terms of those shifts and stretches to help you when you graph functions in my math lab. Once you've gotten this, then it's going to ask you just a little bit more information. What is the asymptote of f of x? And we already said that that's y equals 0. That's a line where y equals 0. You can check answer and say okay. And what is the asymptote of g? And it it didn't change for this. So we can just say y equals 0 and check the answer. How does that look to you, Andrew? Does that ring bells for when you were doing this?
Yeah, that's what well, I mean, I struggled with it just like probably everybody else did until I checked out the video, and
Yeah.
then it was all good.
Yeah, and what I will say is that in the test, if you make sure that you can graph in My Math Lab, that's really important because of course you're going to be doing this in the in on the math test. So the more practice you have in My Math Lab doing graphs like that, the better. But let's say that you do it on the test and you forget an asymptote. I'm going to make sure that I go back in. Just let me know. I'll go back in and I can still give you partial points even if you forget to graph an asymptote. I don't mind going back in. TJ, can you hear us? You're back in. Did it ever come full screen for you? One of the things too, and Andrew, you mentioned it, is that when you're learning this stuff, it's a lot of using the question help and homework, which is great. You will want to try and wean yourself off of using it when you get towards the pre-test because you won't have that option in the test. So a lot of practice and graphing is always going to be your best bet, and in with the logarithm rules as well.
One thing I did find kind of odd was the horizontal shifts and how that they ask you to enter the data for what you want the shift to do. Like if the equation said -3 and you know you're shifting it to the right, you still had to put in -3 to make it go to the right, which is kind of, I don't know, I found it kind of confusing. I mean, I figured it out quickly enough, but
Yeah.
it's like they're trying to mess with your head or something.
It's counterintuitive, isn't it? Because if you had a horizontal shift of -3, you would think that that would move you towards the negative direction on the x-axis, right? Because it's a negative value, but it's flipped in this graphing, and that's because if you were to draw the data table, or sorry, make a data table, you would see that that it doesn't do what you would intuitively think it should do. So you're absolutely right. A horizontal shift of -3 is actually moving everything to the right, the positive direction instead of the negative direction. And the reason for that is just that idea of input output with your data table. It doesn't the data doesn't come out like you would think it would because of that negative positive. But the fact that you recognize that now, Andrew, you won't confuse it on the graph, because I think that's what happens, is that students kind of just kind of brush over that and don't see that that is what's happening, that it's actually opposite of what you would think would happen, and they get it wrong on a test. So even though you find it confusing, you've identified one of the big red flags for this unit, which is good. It might not feel good, but it's good. And TJ, no, that's okay, TJ. I think it's because I was sharing the my desktop, but if I put a whiteboard up now, let me bring up the whiteboard. Oh. So, oh, there we go. Okay, so I have a blank whiteboard up. TJ, let me know when you can see that. Great. So I think the problem, TJ, with yours is that when I go to share my desktop, your window becomes super, super small. And it could be because you're using, like, if you tried using the web app versus the browser. I know when I go in, I just let the browser do its thing. I don't use the app, but but that might change things for you. But we're just going to use this whiteboard for now. Did you want to paste your question into it? I'll see what I can find out from my end too about when you share a desktop and have students that find that it gets really, really tiny on them, and see what I can find through the online group. They might have an answer to that as well. You have a triple question in one. Go for it. Oh boy, that is a big one. Okay, so this is great because Andrew, this is sort of the stuff that you were talking about, right? That makes your brain hurt.
Well, these ones here are just your like common and whatchamacallit, I forget the rules, right? Like the
Yes,
ones
those
you're
are your
looking for,
rules. Yeah.
like your two twos and your. I remember those ones are all ones, I think.
So it's, yeah, so it's like your properties of logs. So that's going to be another sort of study sheet that you're going to want to have. So you have your general properties, you have your common properties, and you have your natural properties. So there's three groups of properties that you're going to want to have access to when you're doing these. You don't have to memorize them, but you'll find that with practice, some of them will come more naturally than others. So first of all, when I look at this, I'm just going to grab a pen. TJ is saying he gets the basis of these, but he just wants to see me do some. Well, and then I have to refresh my memory on these as well, TJ. So thanks for this. First of all, I'm gonna look at the ones that come the easiest, that follow the rules. So the one that pops out at me right away, and it's what Andrew said too, was this one right here, and that's log of base of your base 2 to the power of 3. And when I look at that, the property that I see is, where did it go? Oh, I just lost it. Oh, there we go. Sorry. I'm looking straight at it. So the property that I have is that B, B, X, and that your solution is always going to be X. So when you have these two things that are alike, and let me just get the terminology right for that. Oh, I don't have that here.
I just have this in my notes as basic logarithmic properties. I don't have any explanation. I just know that I
Yeah.
know the answer is 3.
No, it is 3 because of the X. So when these two, I'm trying to figure out I forget what the names of these are. I just having a brain burp. Just a moment, and let me look that up because I like using the right terms. I'll find that out. I can't see it right now, and I don't want to waste your time, but I'll look that up. But anyway, so what you should have is the general rule is that when you have this number and this number are the same, then your solution is going to be X, and they do derive it for you in the textbook. Dun, 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 dun. Let's see. So So they're saying that this is the inverse logarithmic properties. That one's a hard one to say. And basically, and what that means is that any time that you have the same number here, whatever your exponent is on this one is going to be what the whole log is equal to. So that log of 2 to the power of 3, what we're looking for is what exponent would we have if, so we're looking for the exponent that is, there we go, 2 to the power of 3. That's what this actually translates to, right? Because a log is always going to tell us what the exponent is for our base number. So if this is our base, and this is what our base is going to be equal to once we apply the unknown exponent, then you can see right here, logically, our exponent is going to be equal to the 3. Does that make this more understandable about why, if you have these two, if b is equal to b, then the whole log is equal to x that way? Andrew?
Not so much for me. I mean, I see what you've written, and it makes sense, right? Like,
Okay.
2 to what exponent equals 2 to the 3? Well, that's obviously 2 to the 3.
Yes.
But for me to actually, I'll just, I'm just gonna try the memorization and hope that it sticks.
I like to write it like this. Oops. Because if you ever get to a point where memorization doesn't work, then understanding just what the log equation stands for can help you out. So you're always trying to, when you're given a log expression, it's always going to be equal to the exponent on the base. So log of 2, 3 is, oh, I shouldn't say, I should say it this way, because I would have gotten a hard one. What that means is that this is going to be the exponent on the 2, so 2 to the 3 equals 8. That's always going to be the exponent, and realizing that this is the definition of a log can help you if you ever forget the rules, but you'll have the rules with you, right, when you do these types of questions, which is nice. That's the reasoning for just that one general rule in terms of exponents. And if you look at, I'm not sure if that comes across as well in my math lab as it does in the textbook. Like, I find that if you go through these in the textbook, they derive each one of them so that you can see why that rule is the way it is. Like, why is it that when you get something like this, the answer is always going to be whatever is the exponent. So if you're finding it hard to get the connections in my math lab, you might want to try going back to the textbook and reading the section and seeing if that makes the rules a little bit more understandable. TJ, how does that one sound? That's just one of the ones you gave. But Andrew is right. It's applying the rules to the game. TJ, it sounds like you're also having trouble seeing the connections between, like, going from this part here, which is the basic logarithmic setup, to applying a rule to something that's a little bit more complex. So again, if you go back to the textbook, they derive each of the rules to explain why the rule exists, why the pattern exists, because these rules are just patterns that they figured out over time, but there is a reasoning for it, just like I gave here, like the reasoning why log 2 to the power of 3 is equal to 3 is because of this right here. We're trying to find out what the exponent is on 2, and we figure out that it's going to be the 3. But again, it's all with the if you have the rules in front of you, the general properties, common properties, natural properties. I have it on and the natural logarithmic ones. There's actually 4 of them. Have those when you're going through these, and you're just applying the rule to each. So it's also identifying the right rule. So for instance, with this one right here, this one is the rule of b to the power of the log of b x. And in that case, it's always going to be x. So what is x? That's going to be the 5. So x is equal to 5 in that case. And if you're wondering where to find these rules, I believe I've got them in the textbook, which is nice. Are they at the back of the textbook? No, they're not. So you'd have to find them within the section itself. So 4.2 in the textbook has all the rules listed, the general properties, common properties, natural properties, and then the natural logs as well. Yeah, exactly, TJ. Knowing the rules and having them beside you. Exactly. So the last one, and again, just being to identify what rule applies. So this one right here, log 6 with your 1/6. Let me see. It's been a while since I've done these as well, so I'm a little bit rusty too. Oh.
I'm going to take a guess and say it's -2.
I'm 6. Ooh. Let's work that one out because I think you're right. So what we have here, I can't find the property, so I'm going to work it out using this definition, and I think, Andrew, you've got it. So I'm looking for the exponent onto 6. That's going to give me the answer 1/36. And Andrew, you're saying that 6 to the power of -2 will give you 1/36. And you're right, because if we put 6 to the power of 2, that gives us 36, correct? And then if I want it to be 6 over, if I wanted to have it 1/36, then that's going to be, oh, I think it'd be 1/2, wouldn't it? Not -2? I have to remember my exponent rules.
Well, 1/6 to the, or 6 to the -2 is 1/6 to the 2, which is 1/36. So I don't know if I'm barking up the right tree or not.
No, I think I'm just, let me see. 6. I'm just double checking. Yep, you've got it. So 6 to the -2 is equal to 1/36 because that's going to be 6 like that, 1 over 6 to the power of 2. That's what the negative 2 is. You're right. And then that gives us 1 over 36. So that's that one. And the rule for that one, there doesn't seem to be a rule for that one in particular when you have a fraction. So you would have to go back to this idea of, okay, what am I looking for? I'm looking for what is n, what is the exponent. So then I set it up 6 to the power of what is equal to 1 over 36, and then using exponential rules, which is what you did, Andrew, is you're thinking, okay, that's going to be 1 over 6 to the power of 2, which means that n has to be negative 2. Whoop, negative 2. So that one, there wasn't actually a rule for it. You had to instead use what you know about the definition of a log to work backwards to find out what your exponent is equal to, and it involved using the exponential rule that when you have a negative exponent, what you're going to get is 1 over that number to the power, to the positive power. Again, and as TJ said, having the rules in front of you, your general properties, your common logs, your natural logs, having that as a note in front of you when you're doing these and identifying which rule applies is going to help you out a lot than just trying to figure them out from using instead of going back and using the main definition. It's much easier just to identify and figure out which property applies, and if there's no property, then you'll have to do what Andrew just did and infer it from the definition.
It also helps that I just did this question like maybe an hour ago, so it's in my memory.
No, that was good. I have to say, logs are not my favorite. I don't use them ever. So every time I do this, I'm so rusty, it takes me a little while to get going again on them. So I understand the pain of these for sure. I have a note here, and it says putting it all together takes some practice. It's like deciphering a code. You have to first figure out the code, identify the pattern, and then apply the pattern. So as TJ says, if you have the rules in front of you, it's like you're using a deciphering code, and use that to answer these types of questions. And practice makes you faster at these types of questions. If anyone comes across a question that they just can't figure out what is the deciphering rule or how to do it, the best thing you can do is to post it in Q&A or send it to me, and I will figure it out and put a solution up, and then just learn from that. But we try and stick to the properties that we've talked about, and that there's not going to be too much craziness going on with these. But again, you have to practice lots to get used to them for sure. Andrew, do you have another, sorry, TJ, do you have more that you want to put up? I can give us a new page if you want. We still have about 10 minutes. And of course, if you find any questions that you want me to do between now and next Monday, please send them to me. I'm happy to post them on the news feed. Okay, select all. Go ahead, TJ, when you're ready.
So I normally find that the textbook clouds the issue a lot of the time for me, but I think in this case with the logs, I think it's probably going to be the only thing that allows me to grasp it.
Yeah, because they don't, when you're doing the My Math Lab, do they ever give you the general logs and the common logs? They probably don't. It's probably like just kind of just giving you a mash of different types of questions. If you never check the text, you might not know that these rules or properties exist, right? Unless you went back to the textbook.
Yeah, well, I went through the review videos and I make notes from them, but I'm talking about just like instead of memorizing it, like you said, actually sort of comprehending the what happens in order to get that rule
Yes.
to.
Yeah. So with this one, ooh, we're going back to graphing, so we're kind of jumping around a little bit, but that's okay. Let me see, go back to my notes as well with that one. We haven't looked at any of the graphing with logs yet, TJ, so you're okay with this one. Did they ask you to graph this as well in my math lab, or was it just here it is and figure out the domain and range?
No, they just want the domain. This was the
Oh,
question I left right before I came to this session.
oh, okay. So this one we're looking at part B of 4.2. So I'm going to bring that one up. And when we talk about domain and range, I'm just going to put up, whoop. So domain is always going to be the x values of your graph, and the range is always going to be your y values. And because we're talking about domain, we want to know what will be the x values that are found in this function, log 4 minus x. So just our x values. So we're looking at a parent function of y is equal to log bx. And we find that we are going to have an equation. I just want to see if it's which way it's going. So in this one, we're looking at the graph is going to go through, I believe, the parent graph always goes through 0, 0. Oh, sorry, 0 and 1. Getting mixed up here. So 0 and 1. So we're looking at a transformation on that. So we're going like that. And you can see that our values are getting close to our asymptote here, which is y is equal to 0. I mean x is equal to 0. There we go. Sorry. Oh, I'm having a bad night. Shoot. See if I can bring that back up. There we go. There we go. X is equal to 0 is going to be our asymptote on our parent graph. But what we see here is that we have a transformation 4 minus x. So the idea is, what does the 4 minus x look like? But that's not in the right form. And I think that's what's going to mess students up. Do you guys see that? Because normally what we'd have is either x plus 4 or x minus 4. To have it as 4 minus x. TJ, is that what's messing you up? Because that's what's messing me up at this point.
And that's what was messing me up too.
Yeah.
So I put in show me an example
Mm-hmm.
on this question, and the instructions that it gave you were to set the equation equal to 0,
Yeah.
and then solve for x, and then your domain would be negative infinity to that number.
Negative infinity to that number.
If I remember correctly,
Because you're solving for x.
Yeah, I was just stuck on this question right before the Skype session here, so.
I am thinking that because it's 4 minus x, because there's a negative on the x, it's like saying that the whole function, you're setting it to be uh, like a negative. So if I were to put a negative, I would be able to change, that would change what's inside of the brackets here, but I'm not quite sure on it. Would you both mind if I leave on this and try this by myself and get the right answer and do a video for you and post it? Instead of trying, I know that if I tried it right now, I wouldn't, it would be too much fumbling around. But if you leave this with me, I will go and research how this changes that parent function and then get back to you both, since we're all kind of all on the same stumbling block. And if my math lab question help isn't helping, then I'll create a video to help better explain it, I think. And TJ's saying he's fine with that. Are you okay with that too, Andrew?
Yeah, I'm good with that too.
Okay, thank you. I'm sorry. I'm looking at this now going, oh, that's really bothering me. And I know I'm out of practice to be able to do it from the top of my head. So I'll bring that back and get that answered for you, and then I'll post it along with my transformation notes that I promised on the news feed tomorrow.
Well, just out of curiosity, will those be like in a form that I can print?
Yes, I'm going to do it as a PDF.
Awesome, thanks.
Okay, no problem. Well, with that, I think we're at 8:30. We'll stop with this. I'll have this video ready for the newsfeed tomorrow. I'll have those notes in PDF form so that you can just print them out and have them. And then next week, because we still have we have this week and then we have next week to go. I think for Monday I will take a look at the test and pre-test and see if there's anything that we have to look at as sort of a heads up for you before you write the test. It is a take-it-home test, so I don't, TJ, Andrew, are you guys thinking about doing it sooner than the deadline? Like, is it okay to wait till next Monday and we'll have a little bit of a review session then?
Well, I might do it sooner, but not sooner than Monday.
Okay, perfect. That's great. Perfect. And TJ is saying that he's going to do a pre-test before Monday, so that's a great idea as well. And then we'll reconvene on Monday and get out any final questions that we have, and I'll have a look at the test as well, and I can give you sort of what to expect on the test on Monday, and that goes for anybody that's watching at home as well. That we'll reconvene Monday, and I will have what to expect, and we'll go over any final questions as well. But Andrew, TJ, that doesn't mean that the onus is on you guys to show up on Monday. I'll have that ready regardless of whether it's an empty room or whether you're here.
No, unless something comes up, I'll be here. It's my plan.
Okay, that's great, Andrew. Don't get sick. You too, TJ. You have a great week too, and send me your questions, and we will see you next Monday. Thanks, Andrew, for coming in and waiting for us.
Yeah, no problem. Thanks.
Okay.
Have a good one.
No problem. You too. Bye-bye now.
Bye. Take it easy, TJ.